So are we set? Okay. So if there's any need for you to talk, please just write it in the chat. I've disabled you from being able to unmute yourself, because sometimes during lectures you will see a lot of noise that will interrupt. And if there is any question, please leave it in the chat. Afterwards, we will go through them. And at the end of this presentation also, we'll see if there are questions that you need to ask. But this class basically is introduction. We'll introduce the topic or the module, if we call it in this case, software engineering. We're using the software engineering textbook by Ian Sommerville, which is the 10th edition. I was asking about the resources that the previous sets are using, but I wasn't provided one. So I just took off this book from the net, and whatever I think will be shared will not differ very divergent with this. But also, if there is any need for us to revisit, yeah, we'll do that. But what we are doing here is basically introducing software engineering as is the first chapter of the book that we are using. Yeah, Amos, you can't unmute yourself because most of you sometimes mute yourself either accidentally, and you'll see that disrupting the class. So please, if you have anything to say, you may just type it in the chat, either a question or any observation. Just put it in the chat. I think it will be better for organization. So if you are hearing me, yeah, so thank you for the acknowledgement. I was asking for one, so thank you. My name is Dr. Idris Abdul Mumin. I am a staff with the Faculty of Physical Science, Department of Computer Science. And this, I think, will be our first meeting with you guys. But Amos, we've been having some phone calls to schedule this meeting. So thank you. And those of you, and as I see here, let me enable you to unmute yourself so that please you can take just a minute to introduce yourself. And then we continue. So you can now unmute yourself, starting with, yeah, you can.
Okay. Good afternoon, sir. Good afternoon, sir.
Good afternoon.
Yes, sir. My name is Amos John. I'm the class rep.
Okay. Nice to meet you.
Thank you, sir. Thank you, sir.
Good afternoon, sir.
Good afternoon.
Adigun Temitope, the class member, sir.
Oh, okay. Nice meeting you too.
Thank
you. Good afternoon, sir.
Good afternoon. Richard.
My name is Haruna Benjamin Kwage.
Okay.
Class member working in IAR, ABU.
Oh, so you are a member.
Good afternoon, sir.
Good afternoon, Richard.
My name is Bako Saramaso Richard. I'm from Chad, so maybe when you give the lecture, take me in account because the English is not, I don't understand English very well. Thank you, sir.
Okay, our Nigerian English usually is not that complicated, so you'll follow along, trust me.
Yes, sir, we will manage.
Good afternoon, sir.
Good afternoon. Yeah. So yeah, it seems I've met everyone already, so we can.
Good afternoon, sir.
Good afternoon, Comfort.
Yeah, I'm Comfort Johanna, a class member.
Okay, nice meeting you, and I hope we'll have a very fruitful discussion. And I hope the class will also be discussion-based class, not necessarily a lecture-based class. Although I'm meeting you. Yeah, so you see that's the essence of muting you guys, so that we don't hear about the Akwenye and the rest. So introducing software engineering. So what do we do in software engineering? As I think you all know, or you've been introduced to some certain extent in your undergraduate studies, you know software engineering as a course that deals with all that it takes, or all it entails building a software, from getting all the specifications from the customer, or to deploying to end user, to doing all the processes of maintenance, and all the processes that are in between. So why software engineering? What we are covering here will cover topics such as professional software development, and you'll see some topics based on this. So also ethics. Without ethics, I think anyone can build a software that can do whatever. And if you are contracted, because a contract between you and the customer, usually it entails the customer giving you all of their trade secrets, all of their secrets and whatever. There are instances where even you develop a software that pertains national security. So if you are not ethically engaged in those processes, you might bring a lot of problems, either to the country you are serving, to the organization that you are involved with, but also to yourself, because most of these contracts can be enforced either in the court of law or by any arbiter. So we will see some case studies that they said that will be used later in the chapters. And what we are doing here is just to introduce those use cases. As if you are in software engineering as a profession, you will be meeting all of these issues, either not even understanding the language between the developer and the customer during requirement engineering or requirement specification, until maybe you go on like much later in the process of the development of the software, and then there are issues that are regarding even understanding. I mean, you didn't even understand what the person was trying to ask you to build. So getting all of these processes right will solve a lot of your issues, but will also ensure that whatever you are building serves the customer interest, but also the end users will find a lot of satisfaction using the end product that you develop. So software engineering. So as we all know, all of our processes, especially nowadays, involve software. Whatever you are doing, the Zoom that you are hopping on, the phone that you are using, the Google Play Store that you are visiting to download or install more softwares in your phone, to your television, to everything, we all know we are all enveloped, if I will use that term, by software applications. So more and more softwares, more and more systems are software controlled. So if your remote use software, your rocket systems, whatever, airplanes, whatever, they are controlled by software. So even if this was set in 2014, now in 2023, you all know that software are things that you cannot do without. So what does software engineering entail? It covers all the theories, methods, and tools that you use for professional software development. So the word professional software development might mean to some people, if you are into the profession, meaning either you get employed by some people to do software development. Let's say you are employed by a company, or you have your own company that you do software and then you sell to the market. But professional software development should, the meaning should be expanded, if not done so, to mean whatever software you are developing, you try to go along or inculcate all of these theories and methods and the tools that that entails software engineering. It will save your time. It will ensure that whatever you are building is not inefficient. It's also useful. It's easily maintainable. It's dependent. It's or it entails or it inculcates all privacy, ethical, security, whatever issues. So if you follow all of the processes, the theories, whatever that are in social software engineering, you build a software that will stand the test of time. So the expenditure on software represents a significant fraction of gross national product in all developed countries. So even countries that are not that developed, such as Nigeria, which we may classify as a developing nation, you might find that software, like a lot of agencies, a lot of ministries, a lot of departments of government spend a lot of money to develop software. And I think especially during the last government, during I think the tenure of Professor Fantami, you see there was this drive to make everything become digital. And even there was the rebranding of the digital, the Ministry of Communication to be Ministry of Communication and Digital Economy, that everything should be digital. So software cost a lot of money to build, but also if you make it your profession, you can sustain yourself in that profession. So software costs. So the cost between developing a software and developing the hardware is somewhat even not non-comparable. So developing a hardware is one, but developing the software that will enable the hardware to be useful is another. So you have one hardware, like you buy a PC one time, but you may be buying a lot of software, especially in countries where people like using genuine products. I know there are a lot of provisions for getting cracked software or whatever. So sorry, there is a call for prayer here. Let me finish so that it wouldn't interrupt. Sorry, I've allowed you to be able to unmute yourself, but please be responsible with it so that we don't be like robots just talking through chat. You can unmute yourself whenever you have something to say or whatever, but please be responsible with that. Can you hear me? Amos can't hear me. Can you hear me?
Yes, I can. It's now I can hear you.
Yeah, before I muted because there is a call for prayer here.
Oh, okay.
Yeah, so yeah, so please you can be unmuting yourself whenever the need arises. So software costs more to maintain than develop. So usually in a lot of software that you see, to maintain that software, because we have different sort of maintenance which we'll see during the course of this module. So to maintain a software costs you a lot, especially also if you do not follow the processes of the structured processes of software engineering. It takes you a lot to maintain that software, because sometimes to discard the software and develop something new, it might require like a lot of investment, a lot of redesign and the rest. So sometimes it's better for you to just continue maintaining it until maybe a point is reached where the cost of maintaining is less than the cost of developing a new system. So, and you all know costs, sometimes it's not just monetary costs, but even the time, the downtime that you will have. Let's assume now a bank want to change their software. So it's better for a bank to update their new software than to just discard another one. And just, I think there was an example, current example with GT Bank, when I should say recent example with GT Bank, where they discarded their mobile app and then reintroduced a new one, where I think it took us more than 3 days without able to log in into our account to see whatever we have or to do transfers and the rest. So sometimes you have to weigh between the cost of maintaining an old system with developing a new one, new software. So the cost engineering is concerned with the cost-effective software development. So all of these processes are well-defined processes that if you follow them, first it will enable you to mitigate against redundancy. So you don't need to be creating things that are not useful. Also, you don't need to, you assign whatever responsibility to everyone that is developing. If, let's say, you are doing bit by bit development, where each person knows what he is doing, and at the end, you just couple them together. So there are a lot of these processes that makes it cost effective rather than just developing something without a guide. And at the end of the day, you either waste all of your money or you waste significant amount of your budget. So the software project failure, so increase in system complexity. So the usually a software starts from something small, and as it grows, it incorporates new modules, new systems, new new capabilities, and the rest. So if you do not follow all of these techniques, you might build a system that cannot be easily like enhanced, or the complexity cannot be improved upon. So at the end of the day, you may, to just incorporate a new, let's say, functionality, you may have to start building a new software, which will cost you a lot. So the failure to use in this method also said, it is very easy. You can just wake up and just write a computer program without using these techniques. So, and most of the previous applications or development of this software followed this way. People will just wake up and say, yeah, we need to automate our process. Instead of using manual, we create a software. But those software, you just get a person maybe within the organization that knows how to write code, and then they write something. But when your company keeps on growing, that software, you will find it either very obsolete and not even capable of getting much more capabilities as your company is growing. So also it's very expensive, that, and it's less reliable. So the software that you will develop at the end of the day will not be that reliable and will be failing most of the times. So these are some questions that are asked, like how do you define software? What makes a good software? What is software engineering? What are the fundamentals of software engineering, and the rest? As I said, this book is Software Engineering by Sommerville, the 10th edition. So you'll find all of the questions to this and answers to all of these questions. They are in the book. They are also in the slide, which after these lectures I will share. So software product may be developed for a particular customer or a product. So, but you all know what are software, just computer programs that either enable the computer to work or it enables you to automate some manual processes. There are different types of software, which you know. And so what are attributes of good software? So it should, the main thing for any software is whatever the customer wants is what you build. That customer may come maybe at the beginning of the process to tell you that he wants this, and that. You may discuss with the customer to find out that even that what he is trying to say is not achievable, or there are better ways to achieve what the person is. But at the beginning of the process, you should all agree that, yeah, this is what I need. And when you build the product, the customer will say, yeah, this is what was agreed upon. Because there are a lot of like cases, like you will see a lot of I don't know law that much, but let me say cases. I wanted to say civil cases on this, but I don't know whether it's a civil case or not. But there are a lot of court arbitrations on software, either I think the issue between, is it Amazon and Apple sometimes about stealing software, copywriting software, or you build a software, a person will say, no, this is not what I want. But if there is no good documentation, the person will insist that that's not what he wants, even though that was what he said that he wants. So most of these things, you will see the difference between software engineering and system engineering. So system engineering is all the talking about all of the computer-based system, including the hardware and software. Software engineering is just on the software part of it. So key challenges facing software, you will see coping with increasing diversity and demand, whatever. So sometimes you develop a software and then the problem is maybe the systems that are supposed to support that software maybe are being phased out, let's say next year. So that software may become like it's not even useful for you in the next 1 year, which ideally, if you are building software, you build a software that will stand the test of time. So you will see all of this, and they are self-explanatory. Some of them will explain during the course. So there is this software product, generic, customized product. So generic is whatever software that you'll just go online and just use it. Sometimes you need to pay, sometimes they are free. So let's say calculator is a software. Calculator can be used by any person. But there are also customized products, which includes a product that will be made just for you. Although we may say bank applications or mobile applications for banks are generic, but there are like features that are specific to some banks. So even though maybe you get the generic application that will be able to do transfer, check account balance, and all of the rest, there are some specific features that will be different across products. So you can categorize it that there are generic features and then there are customized features. So, but here you are talking about the whole product. There are products such as software for CAD, for graphic programs, for management, project management, that are just generic. Anyone can use it without any modification. So there is this embedded control system, air traffic control, and traffic monitoring system that are specific to various countries, but in some countries also specific to various states or localities. That's a software that you may use in Abuja, might not necessarily work in Kano, because you have two different traffics. So you have to study the traffic management here in Kano. You have to study all of the cars, the whatever that you have, to develop something that will work in Kano. And if you deploy it in Abuja, it might not work. So product specification. So specification of software should, the specification of what software should do is owned by the software developer, and decisions on the software change are made by the developer. So if you are developing the software, you have to inculcate what it should do in the development, but that will be determined by what the customer needs. So the customer will tell you that I need the software to be able to do this, to be able to do that, while in your own development, you inculcate all of those things. If there are things that you might make changes to, it should be with the consent of the customer. So the customized products is the specification of what the software should do is owned by the customer. So the customer will tell you exactly what he wants. So in this, if you look at this generic product, maybe the consumer might tell you that I want you to develop a mobile app for me. The mobile app, what will it do? It should be able to allow persons to interact with their bank accounts. So that customer may not necessarily tell you that you need to log in, but you as the developer, you know that should be a feature. But then he might tell you that, yeah, we used to give loans there. Let's say we have quick credit, we have student loan, we have whatever. Maybe that another bank do not have that necessary things. So those are the customized aspect of it. But then you must have, like, let's say account balance, whatever, that is just a generic that you just put them in as part of the software. So what are the attributes of a good software? So to see a software and say, yeah, this software is good, what does the software need to have to be able to be that? So that software first, you must, that software must be able to, you must be able to maintain it, either yourself as the developer, or any other person with good documentation should be able to maintain the software. So if the software is not that maintainable, maybe you just develop a software that you are the only person that knows whatever is happening. So how about in a situation where you are either not around or you die? Then how will that software be maintained? So maintainability is something that you need in a software. So software should be written in such a way that it can evolve to meet the changes of the customers. This is critical attribute because the software change in an inevitable requirement of changing business. So whatever business, the business that you are running today will most definitely be different from the business that you are running next week or next year or whatever. Because even if the same processes you are doing, maybe the scale will either shrink or it will increase. So now let's say you are developing mobile phones and you are developing 10 per day. Maybe by the end of next year, you'll be developing only one, or you'll be developing 1,000. So that software should be able to accommodate all of this, because we said there are different types of maintenance, which we'll see during the course. So also dependability and security. You must have a software that is always dependable. As I was given an example with the mobile application, when you want to log into your system, mobile app to do transfer, and the application is not working, or it's not very secure, meaning that anyone can just log into your bank using that mobile application to access your fund or to do transfer or whatever. So those software that you are developing must be dependable, but also must be secure. It must be efficient. You want something that you run across a lot of devices while consuming a lot less resources. So you don't want to develop an application that if I install it in my phone, maybe even for the application to finish opening, it will take, let's say, 10 minutes. You don't want that. What you want to do is you want to optimize everything so that it is as efficient as possible, but also should be acceptable. You don't want to develop a software that at the end of the day, if you deploy it in the market, the users will not like it. So you develop a mobile application for a bank, but then the most users will prefer going to the bank physically than even using your application. So you see all of the goal or all of the objective of doing that development have been defeated because your application is not acceptable by the customers. What usually companies want is, if I am developing this, maybe I finish all of the studies to see that, yeah, I need to develop a software. What they want to do is the study should be that after deployment of that software for the end users to use, they want to see some changes, meaning the application is simplifying most of their works. It's not maybe the amount of people that goes into the bank decreases. You don't want an increase on the amount of people because they want to simplify all of their processes. So your software must be maintainable. It must be dependable and secure. It must be efficient. It must also be acceptable. So, and this acceptability, sometimes you might even think of it to even the customer, because you might finish developing all what you want to develop, and then you present to the customer, and the customer will say, no, I don't want this because that's not what we agree upon. But think more of acceptability also on the users that are using, because most users that will be using your software are not that technically sound. So you want to make it as simple as possible for them to use without so much hassle. So do you have questions before we continue? So I think we might.
Good afternoon, sir.
Yes, who is talking?
Yes, it's Yakubu Mohammed, sir.
Oh, okay, so you joined us.
Yes, I just joined, sir.
Okay.
Yes, my question is, as the course implies, software engineering, sir, I want to know if a software engineer is the developer, sir. That's one. Then I met you talking about the generic and the customized type of software. Are they different type, or what classification is generic and customized, sir? What type of classification is generic and customized software?
Okay. So thank you for this. You can mute yourself. Yeah. So thank you. Okay. Yeah. So your ask was who is a software engineer? Is a software engineer the developer? No, we said software engineering entails all of the processes from even inception, the software inception, up till the deployment. A developer will come in when you are implementing. So a developer is one person as like in a group of software engineers. So as a software engineer, you might say, yeah, I want to be very good at doing development, or I want to be very good at doing maintenance. So like it's a big system, should I call it system of people, system of processes, system of whatever. You can say a software engineer also as a tester, because if you are doing software engineering and if you are doing let's say certifications on software engineering, you will be seeing the certification in development also, maybe knowing different programming languages and being certified in that. But there is also certification for testing, reliability testing, user acceptance testing, whatever. It's certification for even maintenance. And there are people that do not know anything about coding, but they are very good in listening to the customer to even know what they want during specification elicitation. So a good software engineering team consists of many people, not necessarily only the software developer. So if you want, as a software developer, you want to start all from imagine you want to build a software for, let's say, Central Bank of Nigeria. Do you need only a group of developers to get that for you? No, you don't need, you need more than that. You need people that will go and sit down with CBN as in management position. You need people that are workers. You need people that are testers. You need people. So software engineering is all of these processes. It's not necessarily only like coding. Coding is one part, which is, we can even say, the most important part, because after listening to the customer, you need to implement. And if there is no developer, there is even no need of listening to. But if you have only a developer might not have like very good understanding or listening. You might have, usually developers are people like very sharp people, and they do whatever they want. But you might have an intermediary between the developer and the customer, so that the intermediary will understand what the developer is saying, but also will understand what the customer is saying and provide this mediation between. So these are this. So also we are talking about generic and customized. I think in the name is just self-explanatory. Generic is, I want to have a MacBook, and this MacBook should be able to on. This is just a generic feature. If I switch it on, it should on. If I switch it off, it should off. If I have like an application that is able to do Zoom, is generic. People will need application to use Zoom. People will need application to write. But if we come to specifics, if you go to the bank, what the bank will need will be different from what a school will need. So, and this is all like putting it in a big umbrella of schools and banks. But if we even break it down to what GT Bank will need will be different from what Zenith Bank will need. But also, this is taking it as bank and bank. You may go into the bank and see what maybe the accounting department will want will be different from what, let's say, the marketing department will want. So these are like customized or specific to their own needs. So that's why we said the generic, you as the developer will do all of the development that are generic. You know all of the features that the system will need, even if the customer did not tell you that, you know them. You need, let's say, user interface. That's a generic that's a generic feature in software development. You need user interface. You don't need to give them access directly to your database. So those are some generic features, generic products. And if we say generic product also, I give example with a calculator. So a person will just go and just get a calculator and use. You need, let's say, an application online for picture editing. You just go online, you just see maybe you want to resize your picture or whatever. You just go online, you see it, and you just use. Those are generic. Anyone can use it. But there are things that you have to customize to your own need. You as the customer, you know what you need. So those things are the customized features or customized products. I hope this answers your question.
Yes, sir. Thank you, sir.
Okay. So software engineering is an engineering discipline. And there is this argument also, where does software engineering feature? I think there was an argument during some discussion, let me not say where, but that software engineering should be in the faculty of engineering, not the faculty of science or physical science or computer science or whatever, because they said software engineering. But software engineering, as you, is obtainable across the world. It is in the computing department or wherever the computing department is located. It can be in the science or physical science or mathematics if it is in there. But then engineering, what comes about engineering? You know, engineering is a discipline that tells you do this, do this, do this methodically. So you have theories, you have methods to solve a problem, bearing in mind organizational and financial constraints. These are engineering. What engineering tells you is there are specification for doing this, there is specification for doing that, there is this, a discipline. So software engineering is an engineering discipline that is concerned with all the aspects of software production from the early stages of system specification through maintaining the system after it's gone to use. And I think this is what I was explaining. From specifying what you want until you give the user and the user is using it and you are trying to correct some of the errors. So that's why sometimes software, you see version 1, version 2, version 3, all of those, they will be telling you, we corrected this error, we add this feature, we corrected this, we corrected that. Because user feedback is enabling them to find out errors that maybe we are not envisaged during the design of the system or even during their own internal maintenance and testing. So user might be using it and then we'll see a problem and then they will report it, and then the people that are in charge with the maintaining will help either resolve that error, or if there are things that the user will need, the people maintaining will go back to the development and then they will say, incorporate this, build this and build that. So it's all aspects of software production. It's not just the technical process of development. Another explanation that I give. So it's not just writing the code. You are using Python, you are using Java, you are using whatever. This includes all the aspects of software production. So the project management is in it. You see, there are people that don't know anything about coding, but they know how to manage the project. The development of the tools, the methods that you are using, the software support software production. So all of this entails software engineering. And I hope, please, if you may unmute and tell me that you understand what I explained now. Anyone?
Sir, can you come back a little bit, sir?
Where, coming back to where?
Okay, the engineering discipline, sir.
Okay.
The engineering, I'm seeing it on the screen, sir.
Yeah, no problem, I will. We have another new person. Now, if you please unmute your, mute, sorry, yeah.
Okay, sir. Okay.
Oh, okay. So we said software engineering is an engineering discipline that is concerned with all aspects. What make it an engineering principle? Because you use the discipline of theories and methods, meaning you are guided. Whatever you are doing is guided. You don't just wake up as a computer scientist and just think of a problem and start solving it without the methodology that is involved in doing that solution. Because most of us, some computer scientists, what we do is we just think about a problem, we just solve it without following anything. I may just wake up here and see that here, my house light is not on that well. Let me just write a program that will just do it. So you don't have that discipline in engineering, because engineering, all of those engineering courses, if we can classify them as that, they involve some discipline, they involve some code. They will tell you this is the specification of this product. If I am developing a chair, or if I am developing, let's say, a car, there are this code, there is this code, there is this code. For the tire that you are building, there is some code that specifies some specification. So this discipline that is brought about by engineers That's what we say software engineering, because software engineering is all about a discipline, codes, method that will tell you that this is how you do this, this is how you do that. If we go into the course more elaborately, you will see that in software specification or system specification, you will see that there are codes. In doing the implementation, there are codes. In doing the testing, there are codes. In doing whatever, ethics, there is code for ethics. There is everything in that. So this is what makes it as an engineering discipline, because you are guided by principles, by methods, by theories, by whatever. So what makes it important? So what we do nowadays, we rely on everything software. Everything is relying on software. The fan, the fan that you are using now is controlled by a remote. The light that comes to your house, the systems that manage that power systems are managed by software. The aeroplane that carries you wherever you are going is managed by software. The nuclear weapons, nuclear energy reactors, whatever, television, fridges now are this. So if all of this, sometimes they are mission critical, but sometimes also you need the trustworthiness in them. So trustworthiness, if you are using software to manage a nuclear weapon, you need that software to be trustworthy. And what do we mean by trustworthy in this sense? You mean that one, it should be able to allow you control, because some software can just start controlling themselves by themselves and start attacking another country. But also some software, to be trustworthy, it should be immune from outside attacks, so that now I'm sitting in Nigeria, I don't have access to the nuclear weapon in America. So all of this software engineering methods ensure that you have that discipline to build software that are reliable, software that are secure, software that are maintainable, software that are trustworthy, software that are this and that. So it is usually cheaper in the long run to use this method than not. If you write a system, let's say it costs you, let's say 1,000 Naira to finish writing that software. At the end of the day, if you do not follow all of this software engineering method, and maybe you just spend only 200 to just get a coder and just code everything for you, at the end of the day, all the problems that might arise if you are deploying that in your environment, with all maintenance, with all scalability, with all of these issues, it might cost you more than that 1,000 that you did not spend to do the development in the first instance. So it's better for you usually to follow this software engineering method than not. So for most type of system, the majority costs are the cost of changing the software after it has gone to use. So if get a developer and it's the person just develop an application for you, and then you go into the market, and then that market says, no, you've not implement a feature that we want. And then you want to implement that feature, and then that software is not easily rescalable. So you couldn't add that new feature. So you have to throw away that software and then develop a new one that will be able to incorporate that feature for you. So those sort of problems usually are as a result of not following religiously the software engineering methods. So, and what are the activities that are involved in software development? So first, and which is the most important, is getting the specification known. Getting the specification known from the customer, but also with the guide of the software engineer or the representative of the engineering team, so that things that can be done should be known, things that cannot be done should be known, things that require modification also should be known. And at the end of this process, there should be an agreement or a document that specifies an agreement between the customer and the engineering team, so that at the end of the day, you have something that you can use against any future challenge. So that a person will tell you that, yeah, I specified this. A person will say, no, I didn't specify this. Or you say, yeah, I specified this, even though they did not specify, and they will start charging you or telling you that since you did not do this thing, you have to do it for free because they said it at the beginning. So there should be a document that document all of the specification agreed by you and them. and signed by them and signed by you, and a copy with them and a copy with you, so that all of this will be mitigated. Then after you get the specification, then you come to the development. This is where you start doing the design, all of this, your UL diagrams, and your design of the database, including all of what entity depends on what entity, what relation this would have to this, and whatever comes during the development process of the software. Then you come to the validation. This is where you sit down with the customer and the developer and whoever that is required to validate, meaning I tell you to design this thing for me and you finish designing. So now we sit down, we give it input, and it produces the exact thing that I want. So this is now you do the validation, and this validation involves various type of testing that you will do. So then it starts the evolving software evolution, where the software is modified to reflect changing customer and market requirement. So now what I have is just able to, let's say, do transfer, check balance, and whatever. But at the end of the day, maybe the customer wants to apply loan. So it's now evolving. So I will say, please come and incorporate a feature that will enable the customer to apply a loan using the software. So you see, at the beginning, during the specification, it was not part of it. But because now the customer wants it, you will develop it to meet that. So the general issues that are affecting software. So heterogeneity. So what do we mean by that is you have different platforms, different networks, different whatever that are trying to use the same software. So sometimes you design software for Android, but then that software is not cannot run on iOS or cannot run on Windows. Or you design a software that deploy it on a distributed system network that include different computers and mobile devices. So you have to take that into notice, because you may not say, I'm targeting only these people that are using this specific product. No, that software will be used by many people and the rest. There is business and social change. So business and society are changing quickly as emerging economies develop. So new technologies become available. So whatever software that you are designing, you put it in at the back of your mind that there are sometimes that even the phone, they will say, we don't support Android 9. Now it's only Android 10 and then above. So if you just design a software that cannot adapt to that change, then you have a problem. So most of these things are just things that you take into notice when developing a software. So security and trust, I've explained this. The scalability, I've explained that. These are all issues. So the diversity. So there are many types of software system, and there is no universal set of techniques that is applicable to all of these. So as you will see, there are, like, sometimes it's just by choice, by the engineering team. We like doing processes like this, or maybe you will get a customer that do not want that. Maybe before they are doing manual processes, but also then they develop, they automate the processes, but using some specific techniques. So if you are employed to design something for them, those people will say, no, you have to use this specific technique to do, because that's what we use in this organization. So you see, there are different types of the software system, and then the software techniques that is used. You have to be conversant in all if you are like going into this as a professional. And there are different factors that will make you to use some specific techniques. Sometimes it's what the user wants. Sometimes it's you'll see that maybe using this specific software technique is better than using another one, because maybe it will cost you a lot less or whatever. So software engineering methods and tools used depend on the type of application that you are developing, the requirement of the customer, and the background. So all of these things too are self-explanatory, I believe. So there are these types of applications. Standalone application, an application that you run only on your computer without necessarily communicating with another person. So, and we have a lot of them in our own computers, you know. We have interactive transaction-based applications that transact or communicate with other applications, such as, let's say, WhatsApp. WhatsApp, you see, you do that communication. Mobile application for bank also does that. They are interactive transaction based. There is the embedded control systems, which we all know. These are systems that do not require you to run them. They run themselves, such as now you want, let's say, your fridge, whenever it is very cold, it should stop. Whenever there may be the temperature rises to some certain level, it should continue. So these are embedded control systems, such as also in aeroplane. You will see that there is the autopilot mode, whereby if you go to some certain altitude, the pilot can even go to the toilet and the aeroplane driving itself. So these are sort of software that are critical, and they must be trustworthy, they must be secure, they must be reliable, whatever you see. So there's these batch processing systems that are designed to process data in large batches. So let's say financial data in the stock market. So these are a lot of data that are generated in real time. So these are systems that require software that will process these large batches. Example also Google search, where tons of millions of data are generated or are created every second. And those software should be able to handle those. Entertainment system for modeling and simulation, which are also self-explanatory. There's data collection system, there is system of system, meaning a system that incorporates several other systems into one. So the fundamentals of software engineering. So we said software engineering requires a lot of all of those things that we saw before, but for every software, there are principles that are fundamental to all of them. The first one we said the systems should be developed using managed and understood development process. So, and I will see all of those development processes. Of course, different processes are used for different types of software. Dependability and performance. All of them should be dependable, meaning if you are using it today, you should be able to use it tomorrow, next tomorrow, even if your organization become bigger or your consumers change or whatever, that should be dependable. You don't need to open it in the morning and then maybe in the distance it's not working. Or you go on autopilot on an airplane and then it starts not working. It's not that reliable. So you have to get a software that is dependable. You must understand and manage the software specification and requirements. You don't need, or you can't not understand specification, and then you just go and develop a software, and at the end of the day, the customer will tell you, this is not what I want, because you did not understand the specification. You did not manage the processes of elicitation of the specification of the software and what it requires. So where appropriate, you should reuse the software. So instead of developing everything from the scratch, what you need to do is you just get a lot of components and patch them together. Example of this, I think, is if you are developing a web application, you can go into Bootstrap and get a UI that's already been designed for you. You just get them. You will see a lot of pages that will say these are forms, these are tables, these are whatever. So whatever you need, you just plug and play, plug and play, plug and play, instead of trying to develop a new table yourself, new whatever yourself. So it's better because all of those components in most cases have been tested by a whole lot of people. So it's easier for you to just pick them as they need. If there are things you will adapt, you adapt, but then it saves you a lot of time and saves you a lot of effort to then writing a new software. So internet software engineering. So this is just like something similar. Developing the web is a platform for running application, and organizations are increasingly developing web-based application rather than local systems. So most of the applications that you see, and I think there is this Microsoft Excel, I think, most of their components, and also Google Documents, their spreadsheet, their whatever, usually they are run online. So if you have just the access to internet, you don't need to start installing whatever on your computer. You just go online, do your spreadsheet, you go online, type your document, you go online, do whatever, rather than just putting it on your local system. So also the automation of record keeping in hospital management, hospital systems now, that is going on most teaching hospitals, federal teaching hospitals. You see most of their systems, you just log in online, fill in customer patient report and whatever. So all of the applications are based online, not necessarily on your computer. So the web services allow the functionality over the web. There's this cloud computing also. You see in cloud computing, infrastructure as a service, platform as a service, allows you to just run the application while you pay. So all of this, I think Adobe systems, you will find them online, where if you just want to work, you just go online, pay them, do whatever, and then you store them on the cloud. Yeah, so you don't need to buy the software. You just pay, instead of buying the whole software, let's say for £1,000, you just pay, let's say £5 to just use it one time, and then maybe that's the end of your usage. So web-based software, web-based systems are complex distributed systems, but the fundamental principle of software engineering is applicable to them, because whatever system that you are building, we said there is a system of systems. So you get a system for whatever task that you are doing, and then at the end of the day, you match them to be system of systems that are online based. So each of those unit component of those systems are developed using the software engineering method. The fundamental ideas of software engineering apply to web-based in the same way as they apply to other system software. So whatever software that you are building is better for you, is more efficient, is less cost, is more cost effective, if I would say, to follow the processes of software engineering than not. So software reuse, how we said, is the most dominant approach for constructing web-based, because you just go and get components from Bootstrap, from GitHub, from wherever, you just couple them together and build. So there is this incremental and agile development also, in which at the first instance, the customer will tell you, I need this and I need that. Maybe during the development, you will find out that, yeah, there is need for this, need for that. So your software also should be developed and delivered incrementally, so that maybe you just finish development of the critical features, a feature that will enable person to check his account balance, to do transfer, and then you deploy that software directly. And then during the course of, let's say, 2 months, 3 months, you add in another feature, and then you just ask the customer to update his own software. And at the end of the day, that feature will be incorporated into the person's software. So this is an incremental development, where you don't need to finish all of the software at one go. You just develop the critical features, and then you continue adding feature until a time maybe when you don't need any more feature. So service-oriented systems. So they might be implemented as just service-oriented software, where the components are standalone web services. So maybe you have, because sometimes you will go online, maybe on a web page, and you will see clock. That clock might have been implemented by another person. So what you just need to do is just use the clock service in your application rather than building that. So just service-oriented. You just incorporate the service. So rich interface web software usually have a lot of materials online, where you can just get adapt them to suit what you need. There are a lot of materials that are developed in Ajax and HTML5. So what we are seeing now are ethics. We've seen the professional software development. And do we have questions before we look at ethics? This, I think, wouldn't consume much of our time. If you have a question, please unmute yourself. We are even on top of the hour. Usually, how long does this class run? Amos?
2 hours, sir.
Okay, so fine. We can finish this course chapter. Yeah, so and also I think if we are having next class, I can't do any one class because I have to be praying after one. So now that we are having 2 hours, that means the lectures will finish in by 3. So which is very late for me to pray. So by next time, we can start the class a lot earlier or a lot later. We can do evening or we can start, let's say 12 to 2. By 2, I think it won't be much late for me to pray. So after today's class, please, whenever you are arranging a class, try to arrange it considering the time for prayer. Amos.
Okay, sir. Yes, sir.
Okay.
Yes.
So ethics. What are ethics? All of us know ethics. These are just like some set of do's and don'ts that guides our own behavior. So don't do this or do that. It's better to do this rather than do that. This is more ethical, whatever. They are all like borderline the same. So software engineering involves wider responsibility than just the application of technical skills. It's not that you just develop a software. There are a lot of responsibilities, and sometimes these responsibilities can even put you in problem. You might be employed by, let's say, Nigerian military to develop a software for them. After you develop that software, maybe it will take them like 2 years. They are monitoring you to see whether you are trying to compromise them or not. So these are some sort of things that you will get yourself involved. So if you are not that ethical or you are not following software engineering ethics, you might lead yourself or your immediate family or whatever in hot soup. And I think most of us here watch American films. Sometimes you will see a person developing software, and after they finish, they get killed because the owners of the software do not want that person to even pass the knowledge to another people, because there is a lot of either competition, there is a lot of treason that is attached to that, espionage, whatever. So there are a lot of responsibilities if you are going into professional software engineering. So software engineers must behave in an honest and ethically responsible way if they are to be respected as professionals. This cannot be overemphasized. You have to be honest. You have to be ethically responsible. Whatever you are doing, sometimes GT Bank will hire you to do software for them. And then you go and learn all of the internal processes of GT Bank, and then Zenith Bank will hire you. Maybe if you go to Zenith Bank, you start telling them, GT Bank are doing this, GT Bank are doing that. And that are their trade secrets. Maybe that's what gives them the competitive advantage over other banks. And you, as let's say a non-ethical person, will start disclosing all of that trade secret. If it becomes known that you are the person that said, you are in deep soup. So ethical behavior is more than just simply upholding the law, but it involves following a set of principles that are morally correct. Sometimes it's not everything that is covered in law. Maybe you'll go to some certain state, let's say in America, where they have different laws. You go to certain state that something is not illegal, and then you just do it. And then you go to certain state that is legal. It's not illegal. Then there it's not legal, you are not doing it, but here is legal, then you are doing it. Maybe, and doing that, since it is legal in there, will not put you in hot soup with the legal authorities, but it might make you like as unethical because you are not that responsible. So maybe that state, if they say you're doing whatever you are doing, that it may cost you either it may cost you your, what should we call it? Your esteem, for lack of better word. So issues of professional responsibility. If you are a software developer, you have to be confidential. Whatever you see and wherever you see it, you leave it there. You don't carry some people's talk and tell another person, because it might result in a lot of issues. You have to also be competent. You don't just because you see maybe the project is very big and you can get money there, and you tell them that, yeah, I can do this, I can do that, even though you cannot do it. You have to be truthful. You have to tell them that this is what you can do. If they find it that, yeah, you are the one that they want to do, they might give you, let's say, like 1 month, 2 months, and say, maybe go and learn this, so that if you come to work, you are that competent in that. But don't collect and then maybe start building your competency before the people know. And then maybe afterwards you develop something that is substandard. So you have to be confidential, you have to be competent, you have to respect their intellectual property rights, because each organization will have its own IP. That IP is particular to them. sometimes registered or even not registered. If they register it as patent or copyright or whatever, that's even made more formal. But there are times where maybe you have these small businesses that are not even able to register their intellectual property. So you have to respect that, even if it is registered or not registered. Then also computer misuse. You should not use your technical skills to abuse. Some people will say, because I know of a person that developed software for other people, and after developing, is a very large agency here in Nigeria. He developed a software for them, and then he created a backdoor where he can log in and see whatever they are doing. That's computer misuse. You have all of their trust that you will develop something for them. Yeah, you develop something for them and they are happy that whatever you develop is working, but not knowing to them that you develop something or you have a backdoor that you are tracking them. Or even some people, since I'm the one that developed, example is IPPIS. So if I develop IPPIS, then I can put all my relatives, I can register them so that they will be earning salary from the federal government. So that is computer misuse. Even if another person did not tell you that is wrong, you know that is wrong. So don't do it. As a software developer, be ethically responsible. So then there are a code of ethics. So that's why we said even ethically there are code. Whatever you have in software engineering as a discipline, engineering discipline, there are codes that will guide you. And this professional societies in US that developed this, the Association of Computing Machinery, and then the IEEE, which is, I think, Institute of Electronics Engineers, I think. Whatever, if that's the right way to say it. So members of this organization sign up to the code practice when they join. So if you join as a computer engineer, as a software engineer, you sign up to this code, meaning you abide by it. It will guide your engagement. The code contains 8 principles related to behavior and decision made by professional software engineers, including practitioner, education managers, supervisors, policymakers, as well as trainees and students of profession. So you have to know them. And they are here. Number 1 is public. All what you will do must be consistent with public interest. The client and the employer will act in a manner that is best interest of their client, and employer consistent with public interest. So most of these things that you are seeing, they are for the good of the public interest, but they are codes, and the codes you must follow. The public, you should act consistently with what is in the best interest of the public. Between client and employer, you shall act in a manner that is in the best interest of their client. As software engineer, the best interest of your client must be in your heart, and the employer consistent with the public interest. Client and employer consistent with the public interest. So whatever that you have at the best, so you cannot be hired by, let's say, a terrorist organization, and then you say, yeah, I'm acting in their best interest. And then that terrorist organization will use whatever you build for them to be terrorizing the public. So whatever you are doing, client, they said, I think in law, client attorney privilege, whatever, there are sometimes that you have to break that, because maybe your client is telling you that today I'm killing the judge. You have to go and tell the judge that they are killing you today, so that the person will know what to do. So all of these things must be in their public interest. So also the product. Software engineers shall ensure that their product and related modification meet the highest professional standard. So whatever you do, you take the best. You don't say, yeah, this will maybe cost me a lot less time to develop, so let me just use this. No, you add whatever you are deciding to do, because the customer might not know all of the ins and outs of doing that development. You as the developer, you know. So I also as a software engineer, you know. So whenever you are developing this product for a client or for customer, you have to ensure that they meet the highest professional standard. The judgment, your judgment should be made with integrity and independence. So whatever you are doing, make sure that there is integrity and there is independence in your judgment, meaning you are judging yourself to meet the highest professional standard, not being influenced by others. So GT Bank will not hire you, and then Zenith Bank will be telling you, do this for them, do this for them. So it should be that, yeah, whatever you are doing, you should be independent in your own thinking, no coercion, but also you should do it with integrity. The managers and leaders shall subscribe to and promote ethical approach to the management of software and maintenance. Meaning, people that are doing software engineering managers and leaders should subscribe to and promote ethical approach in the management of software development and maintenance. Self-explanatory. The profession, software engineers shall advance the integrity and reputation of the profession consistent with public interests and other public interest. Colleagues, you should be fair and supportive to your colleagues, and also you should participate in lifelong learning regarding the practice. So you cannot just learn Python and say, yeah, I know Python. So whatever you are developing in Python, maybe you don't know all of the newest improvements in that. So as software engineer, every day you are learning, every day you will be learning, but also not learning only the technicalities, but also the ethics approach to practice your profession. So that's why I think even in this ethical certification that you'll be doing, if you are a software engineer, you'll be doing it like timely. Not that if you just pass once and then that's all. No, you have to be doing it. And when you are doing it, like, let's say timely, you'll be seeing things being updated. And if they are updated to pass that exam, you have to be updating your knowledge repertoire. So these are case studies that you might be, as a software engineer, be asked to develop a software that resemble one of or more of these. And I think these case studies, you'll find them a lot when the course, like during the course, you'll find a lot of these case studies. But here, what they are doing is introducing them so that at the end of the day, you will be having some sort of like examples that are based on these case studies. And we will not go much in them. We'll just follow or scan through them because most of what we will be seeing are within the course or in subsequent chapters. So ethical dilemma in a person will ask you, please develop a software for me. Maybe your management, or yeah, you are developing, and then there's senior management. Because whatever you are doing, senior management is above you. So you will be developing something, and then you disagree in principle with the policies of senior management. Then how do you do it? And most of these things, you will be seeing it in the case study. They will ask you, how about if your senior manager asks you to do this? Or how about if your senior manager asks you, give me the password to this, or create a backdoor for me in this? How do you do it? Because that senior manager is capable of firing you from the job. So, but also you have to behave in ethical. So employer acts in an unethical way and release safety critical system without finishing testing. So now let's say you are developing a system that will monitor the blood pressure of somebody, and then you finish developing that system, or you finish designing and developing the software, and then without all of the necessary testing, then maybe your manager put it, or your employer put it into the market, and you know that testing has not been finished. So how do you do? Participation in development of military weapons or nuclear systems. As your company now, you are a junior staff, maybe a developer in a company, and then management was assigned by military to develop something that is for their military weapon. You as a worker, how do you do it? So these are some sort of dilemmas that you will find yourself if you are a professional software engineer. So this case study, there are 4 that you will be seeing. There is a personal insulin pump, a machine that will enable the ingestion of insulin whenever a person's blood sugar goes down. So the system automatically should administer that insulin. There is the mental health case patient management system, where this used by maintaining used to maintain the records of people receiving care for mental problems. There is wilderness weather station, let's say, especially in countries such as, let's say, Russia, that most, or like 90% of their country is not even habitable. So most of it is snow, ice, whatever. People are not living there. But then you need the weather reading of those places, so that maybe even in the future you can help detect weather critical conditions, such as, let's say, earthquake or earthquake and all of these windy situations. Then there is the island, a digital learning environment to support learning in schools. So in the case of insulin pump, what it does is it collects data from blood sugar sensor and it calculates the amount of insulin that is required to be injected. So this is like real time. What it will be doing is whenever your blood is flowing, there is this sensor that is recording the blood sugar. So whenever the blood sugar is down, this calculates that here you need this amount of insulin, and immediately it will just administer that insulin for you. So the calculation is based on the rate of change of blood sugar level, and it sent a signal to micro pump to deliver the correct dose. The safety critical system, as low blood sugar, can lead to brain malfunctioning. So this system, as you see, we said you need system that is reliable and dependable. If you design a system that maybe detect that the blood sugar is low and maybe it's not low, and you are giving person insulin, that this will result in high blood sugar. You say it's have long-term consequence in the eye and kidney damage. So you might maybe in the long term just be killing a person without not knowing, because you design a faulty software. But also it might be recording the blood sugar, and maybe the blood sugar will be low without the system or the software knowing. So, and it wouldn't be given the correct dose of the insulin. So, and this can cause brain malfunctioning. It can lead a person to coma. It can kill a person. So you see, this is safety critical system. You have to design a software that is very reliable, very dependable. So, and this is the method. Like you have, if we go in the next diagram, you get the blood sensor to analyze the reading of the sensor, and then it outputs the blood sugar level. And this system computes the amount of insulin based on this sugar level and based on the insulin log. The insulin log will tell you that here at this so time, I've given you insulin, or at this so time, you are required to get insulin. So this is the log. So getting information from the blood sugar level and the insulin log, it computes the required amount of insulin that you are supposed to have. Then it gives the dose. And in that dose, it passes it into the pump that will compute the pump command to tell the pump that give the person insulin. And then that will be saved into the log dose, meaning put in the record inside the insulin log. And then this pump data will be given to the control insulin pump, and then the insulin pump will administer the insulin. So all of these processes are mission critical, because a failure in one of the processes can lead to a severe damage, either damage of kidney, damage of the eye, brain damage, coma, or ultimately death. So essential high level requirements. So the system shall be available. You have to design a system that is available at all the time. Whenever the insulin is required, it should be available. Not that here insulin is required, but there is no battery, no power in the battery, or when maybe there is a failure in the pump, or there is a glitch in the software. So this should be available whenever insulin is required. It must be available. The system shall perform reliably. You see this call for reliability, and deliver the correct amount of insulin to counteract the current level of blood sugar. It must be reliable to give the required amount of insulin. The system must therefore be designed and implemented to ensure that it always meets this requirement. So you see requirement specification. If there is a problem, even in that, at the end of the day, it will lead to killing a lot of people without you knowing or whatever. Hello, are you hearing me?
Yes, sir.
Oh, okay, so thank you.
Yes,
Yeah, okay. So there is then now the ment care. So you see how example of softwares that you will be building. These are not just software that will say 1 + 1 or 2 + 2. You may develop a software that is reliant on, let's say, the stock market of a country. And at the end of the day, or maybe early in the morning, it will say now, yeah, America, the stocks has fallen. even though the stocks did not fall. So it will lead to a lot of panic in the market, even though that software may be glitches. So you don't need a glitch in this. You don't need a glitch in this insulin management. You don't need a glitch in health critical software. Maybe a person is in the emergency unit, intensive care unit in the hospital, and the software is having a glitch, telling you that, yeah, this person require this dose of something, even though that person do not require that. So if you give that person that dose, the person will then die. So you see, these are software that you build if you are a professional software developer. So this Ment Care, what it does is it manages the information of people that are receiving support in their mental health care. So to make it easy for patients to attend these clinics, not just run in hospital, they may also be held in local medical practice or community centers. And most of these things, as information is going down towards people, you will find a lot of problems that the information might be accessed by a person that is not supposed to access that type of information. So Ment Care is an information system that is intended to be used in clinics. It makes use of a central database of patient information, but it's also been designed to run on a PC, meaning you can access it wherever you are, so that it may be accessed and used from sites that do not have secure network connectivity. So, because bring your own device, the issue also, yeah, if a person, you have, let's say in ABU, you have computers that are secure, the network is secure, the computer is secure. So how about if a person is accessing that computer or that network using a computer that does not even have necessarily an antivirus? So you see, it's more prone to attack, that some people might get those information that is not required to be accessible to other people. So when the local system have secure network access, they use patient information in the database, but they can download and use the copies when they are disconnected, meaning you can download the copy and save it in your own system. You don't need to just use it online and leave it there. So to generate management information that allows health service managers to assess performance against local and government targets, it can provide medical staff with timely information to support the treatment of their patient. That's the main goal that they want to achieve by developing that. So, and this is the organization. You have the client, meaning these first three are all customers. And these customers, our client can connect to this network, and this network will give them access to the server, in which its back end is the patient database. So this, you see, during all of this interconnection, you can have various level of either attack or misuse. So the key features in it is individual care management, patient monitoring, and administrative reporting. But the concerns, as we've started mentioning, are the privacy concerns, because usually something that is relating to mental care, you don't need any other person to know, unless the persons that are authorized. And most of the persons that are authorized are the person that have that problem, but also their doctors. So these are what you want. You don't need any other access or unauthorized access. The safety, some medical illness cause patient to become suicidal or danger to other people. So wherever possible, the system should warn medical staff about potentially suicidal or dangerous patient, because you might be seeing a patient, that system should be able to tell you that this patient, you should be careful. The system must be available when needed. Otherwise, safety must be compromised, and it may be impossible to prescribe the correct medication. So it must be available whenever it is needed. So these are wilderness weather station, where you get all of these readings, temperatures, pressure, rainfall, wind direction, and whatever. You want this to be reported at all times, but not necessarily only these weather conditions, but also it should be able to tell you that there is a problem with this, let's say, instrument, or maybe there is not enough power in this instrument, or maybe if the place, the temperature or the climatic conditions are not very favorable, you want to tell it that please switch off the engine or start the engine if this, or I want you to charge, maybe if there is sunlight, charge. If there is no sunlight, don't charge. So all of these things, you see there is a need for all of those embedded systems that will be able to detect all of these conditions and help manage the system as required. So the weather system, the data management and archiving, and the system maintenance system, all of this work hand in hand to give you whatever you want. So the additional software includes the power communication, it ensures the battery are charged, it supports the configuration. So when you need to, let's say, update your software, it should be able to allow you to do that, even though if it is remote, because sometimes you may not even be able to physically visit the place, but you might be able to maintain it. So there is this island which enables the school, let's say school or whatever, teachers to be able to teach their students virtually. And with the advent, or with the outbreak of coronavirus, we also most examples of this virtual learning environment. So yeah, what you have is the student should be able to get a browser-based user interface where a person can log in and start learning. And then there are the configuration, which are done by either the teacher or the application manager to give specific content, to register student, to do whatever management and rest. So these are things that you will see during the course. There are integrated services and there are independent services. So yeah. So integrated services which offer an API which can be accessed by other services through the API. So you have independent services which just access it through your browser and which can operate independently of other services. So to pass information, you can only be shared with other servers through explicit user actions such as copy and paste, such as re-authentication, that is needed. Whenever you want to reuse another service, you have to re-authenticate. So this is the end of this chapter, where we see that software engineering is an engineering discipline rather than just science. It is concerned with all of the processes of software development, from specification, elicitation, up to maintenance after deployment. So you have the essential product. So the attributes, the essential attribute is that a software must be easily maintainable, it must be dependable, it must be secure, it must be efficient, and it must be acceptable, which we saw. There are high-level activities of specification, and development, validation, evaluation, and that are all part of software processes. So you start from specification. After you are very satisfied with all of the specification, you do development. During development, you do design and you do actual implementation, and then validate. That's where you do all of the testing to see whether the product is meeting the specification. If the validation, from the validation, if there are failures, you go back to development so that you redevelop. Sometimes you even go back to specification, depending on what type of software engineering process you are using. So, and then there's the evolution where the software begins to grow and you need to be incorporating all of the new features and whatever. So the fundamental notions of software engineering are that universally applicable to all types of systems. And we also that regardless of the software that you are building, there are many different types of software system, and each require appropriate software engineering tools and techniques for their development, which I will see in more elaborate terms during the course. Then the fundamental ideas of software engineering are applicable to all software. So whatever software that you are using, all of these ideas of software engineering are what you will use. Either is it based on ethics, or is it the codes that guide specification, development, maintenance, validation, whatever. So software engineers must have the responsibility to their profession and society. They should not simply be concerned with technical issues. So this is what brought about all of the ethics and ethical procedures that a person must abide by. You have to ensure that you are very ethical. Not necessarily only you have to like work by the law, because sometimes working by the law might not at all times be ethical. First, you have to work by the law so that you avoid all legal challenges. But also things that are not covered by the law, if they are more morally unethical, you should avoid them. Professional societies publish codes, which we saw there, some eight ethical codes that are expected to be abide by, and they are the standards of behavior that are expected of their members. So this is the end of this presentation. We may choose to ask questions if we have them now.
Okay, sir. Well done, sir.
Yeah, okay.
Well done, sir.
Thank you.
Yes, sir. Sir, maybe after the class, you send the material so that I'll send it on the platform, sir.
Yeah. I don't know the platform that I am in. Is it the one that Dr. Salis used to say you have meeting in?
No, sir. Just send it to my personal platform. I will send it to the
Why
general
not?
platform, sir.
Okay, no problem. Why, no problem. I will send it to you.
Okay, sir.
Okay.
Okay.
Hello, sir.
Yes.
The 4 case study we just looked at now, is that the only one that we are? Do we have more of the case study, or for the benefit of this course, that's the one that we are to look at?
Yeah, you are not looking at now. What you are looking at is that in this chapter, there is this case studies that are summarized, and you will be looking at like more detail during the course. So I believe that if there are more, you will see that there are more. If there are no more, maybe it's just only this 4. What you have here are not like instances. They just introduce to you all of these cases. But you'll have instances where there might be some technical concerns, some ethical concerns, some whatever concerns when you are reading specific chapters that talk about all of this. So you'll be having the direct examples that are based on these use cases. So what you have here are just introduction to these use cases, but you will find more that are specific to whatever you are studying or whatever chapter that you are currently studying. So
thank you very much. I appreciate it.
Yeah, you start the reading here with the introduction. Things
Nice.
that are specific, you will see them during the course. So if we don't have any more questions, we can end the class now, and then we'll see next time. Do you do this classes like every week, once a week, or do you run them whenever you have the chance? Aruna wanted to talk. Amos?
It's once a week, sir.
Oh, once a week for each of the course, is it?
Yes, sir.
Okay, so that means we'll meet by Monday next week, but not the same time.
Maybe 1:30, sir.
1:30. I have prayed 1:30. Yeah, we can do 1:30. No. My
1:30
prayer
to 3.
is one. My
Sir,
prayer is 1:30.
sir, we can do it 11 to 1, sir.
11 to 1 is all right by me, I think.
Okay, sir.
Okay, sir.
Okay, so if this is the consensus, please let's 11 to 1 next week. So see you.
Thank you, sir. Thank you so much, sir.
I hope you don't like stop here. You continue reading so that if we meet next time, if you have any more questions, you can ask those questions.
Okay, sir. Okay.
See you next week. Bye-bye.
Thank you, sir. Have a nice